think that looks good.
Thanks, James. It seems it's streaming now.
All right, we're live.
Cool.
And the ball is yours, Adriano.
Okay. Thanks, James.
You bet. Have fun.
Bye. Okay, guys. Welcome to this new live session. Today, June 6th, and sorry for the delays. So now we're going to. It's maybe Aaron here. No.
Is Nick maybe Aaron or on Twitter?
Okay. Yeah, it
Yep.
was
Yeah,
like
Aaron's my middle name.
on the avatar.
Aha, it was confusing.
Yeah.
Sorry about that.
Okay, Aaron. You have some ideas that I mean, you were invited maybe because of these ideas. Of course, you are invited all the time. Don't worry if you're not a developer. Luckily, GameChanger allows you to code using something called low code. There is a very basic language to interact with the wallet. And there are a lot of demos and stuff built in on the wallet, so you can maybe start getting into places where you're looking to get into without knowing too much, too much about programming. Don't worry about it. So do you want to tell us your idea, and let's maybe discuss a bit how we can help you?
Yeah. So a little bit about my background. I own a coffee shop, so I don't really have any background in computers or coding or anything like that. But a couple of years ago, I kind of got interested in like the crypto space just because it seems really interesting, and did a lot of reading and watching videos about different things, and Cardano kind of seemed really cool just with like the vision of it and the technology of it and everything. So I mean, I've kind of been just like an observer of the space for a while, just on Twitter and whatnot, but not really building anything. But it kind of it occurred to me, running a business and having all like the expenses all the time, and we have like our POS system and payment processing and all that all the time, and credit card fees, and just the amount of money we spend on that type of thing is pretty crazy every year. So I don't know, it kind of in my mind for a while I've been thinking like, man, it'd be cool if there's just like a really simple app that I could be like, oh, hey, customers, if you use this app, you could get, some % off your purchases because it's saving us money on credit card fees and stuff like that. But the whole idea was like thinking about telling all my customers, oh, go buy this wallet and then go to a crypto exchange and make an account there and buy all this stuff, and then, protect your key. Like, it just seems like a really high hurdle to get just like regular people who just want to buy a cup of coffee to jump over, so I was just thinking like, man, it'd be cool if there's like some type of an app where you pretty much download it, and then somehow, there's some type of, I use JED because it's a stable coin, but maybe something else. But just like where you go in, you connect your bank account, you get some crypto, and then it's just a simple send and receive thing. So with Chat GPT, that came out recently, I kind of started playing with like Swift Playgrounds and Chat GPT, and was like, oh, hey, Chat GPT, I want to, build a user interface for an app that I'm thinking about, and then just kind of like went back and forth, and kind of got to the point where I have the one, the little video of just going through the app that I posted on Twitter. and I was just thinking like, oh, it'd be cool, you know, if this if this could actually work somehow. But yeah, and so that's kind of my background.
Ooh, nice. Maybe I don't know if you have been watching what Martin Manier has been doing with hardware devices with Cardano.
Yeah, I remember I saw a little bit of so I found GameChanger wallet like a while ago, and then I saw some videos of like some type of like hardware, like POS type of system where, you know, where like it generates a QR code and you scan it and stuff, and I was like, oh, that's cool. So yeah, I'm not sure exactly, I mean, how all that works or whatever, but yeah, I mean, that's pretty cool.
I can tell you a little bit about it. But it can also be done in just a dApp, just to get started, maybe. Yeah, we were discussing this day, we're doing the workspaces thing, but maybe we can prepare something for you in next session. So we can show you this idea, how it works in practice. And what I do is I made some hardware which makes it very convenient to set up. So this is the PayPad, because yeah, maybe if you put it on a screen, which it's just the generation, you can automate yourself even with JavaScript. But maybe this is not so nice for customer facing stuff. Like you want to not have to turn your screen maybe of your, you know, your point of sale system to show the QR code to the customer. So this is what the PayPad really does. You communicate via a browser interface to this device, and this device shows you the QR code with some extra information, making it look a little bit more polished. But right now we're in the transition from version 1 to version 2. And well, there were some parts shortages due to Corona still. So it really took a long time to get this running. But yeah, a lot of stuff in Cardano, of course, is work in progress. But I think a lot of this stuff will be available quite quickly, like a couple of months. So that would be interesting if this is interesting for you. But for now, we can also just show you how it works maybe next week.
Yeah, that'd be cool.
Because we can do the transaction part, but converting US dollar to ADA is still tricky also for us, I think. But Adriano has been working on something. I don't know if it is also difficult always, because you know, every company has trouble with this. To interface with banking in crypto is, well, it's hard because of regulation, not because of technical situation.
So I mean, it's super possible to do what you are. I mean, a lot of stuff that you are trying to do. Nick, it's okay, Nick. Your name, okay.
Yeah.
So okay, so and the proof is that Martin did it with hardware. I mean, you can do it with an app, and maybe you can do it with a web page, because if the security and all the stuff is solved somehow, you can avoid the need of asking your customers to install an app. Maybe just pointing them to you know, a website, a web app is enough, is sufficient, you know. And even to start without coding, there are some stuff that are already available natively on GameChanger wallet that are ready for you to use. On version 1, the current production version that is on mainnet, and on the upcoming version 2 that is on beta right now. There is a very much powerful version that is coming I mean, closing time from this point of the year. So stay tuned, please, please, please. If you come the next session, maybe we can plan something. we can plan getting closer to your app with low code. Maybe start without the app to show you how you can maybe just now start interacting with your customers with DJet, for example, using GameChanger wallet. So stay. Let's keep in touch. Okay.
Sounds good.
Okay. Cool. Thanks. So today we won't have much time. So let me know if you are not agree with this. We are going to be exploring a bit the introduction of workspaces. And I mean, from the lowest part to the most abstract and easy, maybe level of this topic. So it's okay with everyone. Does anyone has maybe different idea for today? Martin, you? No? Okay. Okay, let's do this. Wait. Okay. Let me know. Are you watching? Okay. So I'm going to go very quickly to a bit of theory. So when we have an address, okay, on our wallet, any address on any, I mean, especially in this case, we're going to talk about Cardano. But basically what we are doing with addresses is referencing other, I mean, some keys that we have on our wallet, okay, that are created, for example, using the seed phrase, the mnemonics that we use to import wallets. In Cardano, I like to explain this, calling this type of keys this way, like a spend key and a stake key, okay? One day maybe we can get deeper into the theory, and then you can understand why I call them this way, and more technical stuff. But basically, let's say that an address references two keys, two pair of keys. Keys came in pairs on the cryptographic theory. You have a public key and a private key. Okay, both the pair is related to each other. The public key is a key that can be shared safely, and the private key, no. The private key is meant to be kept safe and to not share it. Just use it, for example, to sign stuff, sign transactions, sign messages, but to keep it safe. On Cardano, we have two types of keys, spend and stake, let's say. With the spend key, we are able to spend funds. And with the stake key, we can delegate the funds stored or lying into this address. You can delegate that stake power, that stake, to a pool on Cardano. If you have this key that acts like a permission, if you have this key, you can spend the funds. Okay, so when you have a wallet, you can have multiple keys on your wallet. Okay, if you have multiple keys, you can maybe create a sequence of keys. Somehow you can create like child, this is called derivations. You can create like child keys that are based, for example, on numbers. okay? These numbers can be a sequence, can be an index, and can be a sequence starting from 0, 1, 2, you know. So therefore, you will have tiles that you can name, for example, with these indexes, okay? And we're talking about the spend ones, for example, and the same happens with the stake keys. You can have multiple stake keys on a wallet, and you can you know, create them, for example, in a sequence. You can also create these ones not in a sequence. You can create these ones on any group that you want. But we are going to try to explore the reasons behind this derivation scheme or strategy and how this whole thing relates to our everyday use on Cardano and to workspaces. This concept that we are introducing on GameChanger wallet. So when we combine, because for example, the combination of these two references of keys allow us to create a wallet, for example, an address, okay? So if we combine these two, we can have an address. If we combine, for example, these two, we can have, wow, I am making a mess, but you get the idea. If you combine these two ones, you can get another address, and so on and so forth. So, for those who you're wondering, of course, we are talking about this kind of addresses. These ones starting with test are because we're on a testnet, for example, pre-production testnet. And codified inside this thing, this code that is called batch32, we have the different parts of the address. And for example, if we combine here something like this, I mean, we can have the addresses that we are watching here. Very quickly, this is getting a bit technical, but I'm going to show you just the first part of this capture. When we combine different spend key references, but we keep referencing the same stake key, okay, on our addresses, we end up having something like this. Each of these lines is an address, and you can see how we have a part of the address that differs from any other one, and then you can check that you have a part that is common to all the addresses generated on the same wallet. This is when we do combinations between different spend keys and, the same stake key. But what if we do, for example, this? One, two, three, four. If we do this, if we start combining different, also with different stake keys, for example, we end up having this situation where we have addresses that has absolutely nothing in common with each other. As you can see here, all this part that is common, here is not common. I am telling you this because this is a privacy related thing, because this way on the blockchain you can be somehow tracked. You can group by analyzing the ledger, the story of the blockchain. You can track your interactions with all these addresses under your control, and then we can say, okay, all these addresses belongs to the same maybe person because they share this same stake related part. But in this case, there is no way to know it because it's completely different. Okay, this is, I mean, knowledge is power, and when you start getting deeper into the systems and into the different ways we handle our private data, for example, we maybe get closer to have a more advanced or secure or more private usage, okay, of our tools. But with knowledge, with great knowledge comes great responsibility, because now, of course, the deeper you get, the deeper you can mess with this stuff, okay, and you can do something wrong. So, okay, I've just give you an introduction that was very needed with this topic. There is any question or something on the chat? I have not seen this. Are you guys following? Yes?
Yeah, I got you.
Okay. Okay, guys, I need you to try this on your side. Okay, everyone, let's try to do a code together. So stay ready with your playground on your screen. So what we are going to do is we're going to create our addresses on our own. Let's try to recreate our main address, the address that comes by default on your single address wallets. In this case, the address, of course, we have here, and the address that where we store by default our funds. We are going, and I'm going to go back and forth to go quickly. We are going to use this type of function of the API. Aaron, just in cases you're here, there is a lot of material around this syntax and stuff, but okay, this is the syntax and the place on the wallet where we can start building the apps and interacting with the wallet by code. And this is low code, okay? This is not a fully complex programming language. So, continuing with this, what we are going to do is we're going to create some keys here, at least one. And this is the syntax. It's a list. It can be something else, but it's an object. But this is a list, basically. And we can put a name here. Let's say spend 00. The kind is spend because it's a spend key. And let's work with this index called account index. Let's freeze for now this account index to 0 on all our tests. Okay, guys, let me know, is anyone trying this on your end? So I can go a bit slowly.
Yeah, I'm following.
Awesome. Okay. So here we define the list of, let's say, recipes on how to create our child keys. And here we are creating a spend child key called spend00. And remember that index, that number that we can use to name all those childs. Let's say that this is the number, this called address index. To be honest, the two numbers here are referencing different child keys, but let's keep it simple by just using the address index. And here we're going to say, yes, 0, because is the first key. Then we are going to copy paste the same thing, and we are going to say, instead of spend, we are going to say stake. And the only difference between these two child keys or key pairs is the stake kind. One is stake, and the other one is spend. Let's run this thing to see what happens. When I run this code, and I put the password, the wallet is going to ask if you want to derive some key pairs. Okay, we say continue, and that's it. And if we return with data here, we return with the results, we can see that there is some information on each of these, on the result of the spend keys function. We have the same list, but not of the recipes, but the results of those derivation recipes. And we have, for example, the first one being a spend kind of key. This is what is called derivation key. Key here is meaning as a recipe, as an index, okay, as a name or tag, not a key as a key. It's a bit confusing. And here we have the exact indexes that we have been using. And here is the interesting part. Here we have in different formats expressed here and here the actual keys. Okay, but these are the public keys. Private keys are handled inside wallets and are not meant to be shared. And here is what we have been using as a reference. Remember that I told you that we on addresses used reference to key pairs. And actually we have been using this same thing, for example, when minting, that strange, hash that we have been passing to the minting native scripts, or in other cases we have been using to do multi-sign, whatever. So these references to keys are key hashes, are hashes of these keys. We have here the hash of this first of this first key, and then of course we have a different one and different keys generated for the stake. Okay, now we are going to create or recreate maybe our main address. The main address of a wallet is, as I told you, this one, the default one. Martin, go ahead.
I know if you have the Cardano CLI and you do address generate, you get two files, like the S key and the public key. Is this S key or the payment key? Is this not shown here? And is it generated or you have no? You have.
I don't remember the syntax, Martin. That's a good question. I don't remember the syntax there, the name convention on the CLI, but S key, I believe is secret key. I guess.
Yeah, secret key and verification key. That's true. Yeah.
Yeah, verification key and secret key might be the same, I guess. And it's the private key, and it's the one that you should not be sharing. And I don't know the public key, the name, the convention for the public key, but I don't know, I don't remember actually, because I've used this a long time ago. But on the CLI, maybe you are passing entire keys, okay? But what actually the CLI is doing is just using the key hashes to generate your addresses. So the most relevant information that you need to create an address is the key hash, not the key itself.
Okay. Yeah.
And when you're dealing with, for example, a shared treasury, you need the script hash as minimum information there for addresses, okay? At the same level, key hashes and script hashes, but not the key or the scripts entirely, okay? So here we are going to be using the build address. And on the build address type, we need to go quickly. I'm going to copy paste a bit this. For the build address, we need to pass under the address definition the two parts, the two references. And I say two, but maybe we can have one, and we will be building different kind of addresses. But let's use the most common ones, that is called base address, that has a stake and a spend part or credential encoded inside. So in this case, with these macros, we're going to be referencing the results here. And this is spend keys. Hey, I commit an error here. Let's say keys. Sorry, because here we are deriving also a stake key. So keys, we're going to say keys here. And if we check on the results under, well, what's spend keys here, we have a 0 and a 1. So if we say 0 and 1 here, we can access the spend key hash and the stake key hash, okay, on the results of these two derivation recipes, okay? So if this is correct, I should end up with the same address that GameChanger wallet is showing us on the UI. And I have an error on the syntax. Okay, I need a name. I need a name. for this. For this address. In theory, we type name and address here. We are okay. Okay, if I run the code, we have the results of the key derivations here, and the main address is this one. Okay, I'm going to copy the address to double check it. I'm going to paste it here, and I'm going to copy here. If you go, if you click on this icon, you can copy your current address on GameChanger wallet. If you click here and you place the address here, we can verify that we have created ourselves our own main address. And remember, this is the address that you can find, for example, on any other wallet. For example, on Nami, that is a single address wallet. You will be using only this first main address. Now, let's try something different. Okay? Let's try something different. What if I mean, are you coding this on your side? Should I wait a bit?
Adriano, one question.
Yes.
When you do the spend key parts, you have the index 0 and spend key and the index 0 stake key. These were already made before when you created your wallet, right?
Yes and no.
Oh,
Yes and no, Martin. Another good question. When we run this function on the API, we are actually asking GameChanger wallet to use our root or master private key on our wallet to create these child keys. So we are actually creating those again, and maybe because some optimizations, maybe if those are created already, GameChanger can use that cache. But if not, it's going to actually use the private key of the wallet, the root private key, to derive new keys. So to keep it simple, you are deriving new keys here. Okay.
oh, okay.
Yes.
That's new for me.
Okay. But that's a good question. Yeah. So have you tried this on your own? Anyone?
I'm trying it. Would you mind scrolling up just a bit, Adriano?
Yeah, where do you need me to scroll?
Still, I'm up at the keys and the type. So
Here?
great. Yeah.
Cool. In the meanwhile, let's analyze something while you guys can code this thing. So why we sometimes use sequences of these derivations? Like why we start with the index 0, for example, here. Why we start with the index 0, and then why we move to the index 1, 2, 3, and so on and so forth. Why? Because this way we can keep these recipes deterministic. And when I say deterministic, it means that we can agree upon that standard across maybe the entire blockchain space to always deal with our child addresses in a sequence to create first, the child 0, then the child 1, 2, and then use them as a sequence, and therefore create a sequence of addresses. So Let's guys, are you Q? How are you? Do you need more time?
I'm good. Yeah, I'm good.
Did you create your own address there?
Almost.
Okay. Okay, I can wait a bit. Today is not the perfect day. We are not maybe ending the entire thing we wanted to try, but at least it's a nice intro. So we use sequences because of that, because that's we can agree upon that thing. But there is a great deal of there are a lot of reasons because of security reasons, because of all these theory, and one of the things that we can start thinking about is that, okay, if someone compromises my root private key, okay, then if we all agree to create a sequence of addresses of child keys, then it's very straightforward for this hacker or this this thief to recreate our addresses and to access our funds. The amount of indexes that you can use here is huge. I won't say infinite, but it's pretty infinite to me. So what if we want to make a nice and weird experiment? What if we randomize this number, this index, the address index? Why don't we use a random number out of nothing specifically, and we use another one here? So we have randomized the index of the spend and the stake key. I'm going to run this. Remember the same exercise, but just changing the indexes. If I run this, I end up, of course, with a 100% different address from this one that is the main address of my wallet. And there is nothing in common between the two addresses. So that theory that I shown you at the beginning is now in your hands. You can try these things on your own. And please, if you're trying this, why don't you send funds to this weird address, the one that we have generated? Because of the time, I won't be doing it right now, okay? But we have generated an address using randomized indexes. And of course, it's a valid Cardano address. And we can send funds there. Imagine sending a lot of money, a lot of digits, for example, there. Now, if you are trying this on your own, I literally would ask you to select your code and erase it. What? Yes. Delete this code, and now let me try you on your end to recreate the same address that we have just created seconds ago. with randomized keys. So imagine we send a lot of funds there on that address. We lose somehow the recipe on how to recreate this address. Now, can someone remember what indexes we have used and what recipe we end up using to create that address? Well, if you check on the live stream recorded, it's doing some, you know, it's not fair that we lose track of the recipe forever. And if we lose track of the recipe, how can we access again those funds? Because we have not used a deterministic or some other solution to remember and to keep safe the recipe somehow. We have the funds under control because the keys are ours. We control the keys, but we don't remember or we don't know how to access this address again. So, if you have been following me until this point, you can understand why doing this deterministic as a sequence that, of course, everyone can recreate on their own, or by storing somehow the recipe safely, of course, and privately as well. It's nice to have it privately because it's another security layer that we can count on by storing the recipe privately. Only by doing these two things, we can access again our funds on our main wallet address or on any other child address wallet that we handle, that we have. For example, Yoroi, Daedalus, Eternal are other wallets on Cardano that uses child addresses as well. These guys uses a deterministic recipe to find and to recreate addresses. But here's the deal. If you're following me until now, a deterministic way to the right, and I am going to make an example here very quickly. If a deterministic way to the right keys here would look like this. So this is not. This is what? Okay. Here, I am deriving 3 spell keys in a sequence. This is, let's say the name, this is 1, this is 2, the index is 2 here, the index is 1 here, the index is 0 here. Here we have 3 derived keys in a row on a sequence, a deterministic sequence. So this is what most wallets are doing because they are following some standards here. But maybe because of security reasons, or maybe because we need it for something else, for an application, for gaining some more privacy, or for actually doing multi-delegation. Because once again, if I can go back to the theory very quickly, we have here, when we have here this set of addresses, and we are sharing here, and we are sharing the same stake key reference, we are delegating. For example, if we have delegated with this stake key to a pool, we are automatically delegating all these addresses to the same pool. Okay? So this concept of multi-delegation on Cardano works simply by creating your addresses with different, and let's use a sequence if we want to, different state keys. If our addresses use different state keys, we are allowed to delegate to different pools. At the same time, all the funds of under my mnemonics, for example, my seed phrase, delegated at the same time to different pools. And remember, for those concerning privacy, we have a situation like this, where this is the first part, are the addresses created on a sharing the same state credential, and here we have different state credentials, so we end up having different addresses. Therefore, we cannot be easily tracked on the ledger. These are one of the reasons, two of the reasons, why we can be using not a sequence, but actually different different indexes. So storing the recipe or agreeing upon doing it deterministic is paramount, is important. Okay, now welcome workspaces. What a workspace is this. When we run this kind of code, when we derive keys, we create addresses. When we are dealing with stuff that can involve, can produce a loss of funds, a loss of signability or capacity to sign. I mean, with the end user keys, GameChanger wallet creates a thing called artifacts. And these artifacts are the exact same stuff that we have been creating on this exercise, but as items that can be exported or saved for posterity. The items here are not the items themselves, are actually the recipes on how to recreate these things. So for example, I have a key here, and I have an address here. If I select, for example, the address, sorry, okay, this is not what I wanted to do, but I mean, the address here, if I check the address, I mean, we can have information of all these items, of this stuff. For example, if I check this key, I have the index that we used, the kind. I mean, this artifact concept stores the recipe on how we can recreate this stuff. When we store all these recipes into a GameChanger file system or a disk NFT, okay, encrypted, because it's good to have these recipes stored privately as well. So when we do this, when we store these recipes on chain on this file system that we have, we created this thing called workspaces. And there, and I'm going to move here, for example, okay. And here, for example, on this wallet, I have this text here, this message that says load wallet settings, and it says a wallet configuration script has been detected on this address. Do you want do you want to execute it to configure your wallet? When we use this system, we are actually running the same kind of script that we created here, for example, automatically to recreate that organization, that setup, those addresses and keys and whatever, under names and descriptions, and available, for example, on the UI then, like this. If I click here, I have a list of workspaces. So a group of these artifacts is a workspace. Okay, a group of key derivations and addresses built upon those derivations on a group, okay, is a workspace. We can put a name to that group, a name to that workspace, and a description that we can then see here on the UI. For example, let's see, in this case, your stake portfolio. This workspace has this name, your stake portfolio. Then we have this description. And if I click this and I change the current address to one of the addresses that are inside this workspace, I can change, okay, the address, check the address of the GameChanger wallet here and here, okay? Check how if I click here, I can change my current address and switch the view of the wallet to the child addresses that are available on this workspace. If we don't deal with key derivations in a sequence, in a deterministic sequence, but actually we free these recipes to be arbitrary, to users to do whatever they need to, or the apps to do whatever they need to, and we store those, we end up having a system like this, when we can have group of different purposes, of addresses, keys, and other stuff, and we can, in simple words, customize our wallets to the user experience we need or we want. Because, for example, in this simple case, is literally your stake portfolio. Is a multi-delegation setup on your GameChanger wallet that allows you to delegate to different pools. If I use this widget here, if I delegate this address, this other address, and this other address to its corresponding pools here, we have multi-delegation, and we have got ourselves out of the standard because we needed a special use case. Okay, and we need to simplify actually our lives, because now the address is not a number, it's not an index, it's a name. We say alpha. That alpha is the ticker of the pool. For example, we can be delegating this address into. Okay, I know it's too much. It's too much because this was an intro, but it's nice if we can, roll the knowledge slowly towards these more complex and abstract concepts like workspaces, actually. If you want to create a workspace by UI, no code by UI, you can go to Discover and you can go to Workspaces. And here we have recipes, common recipes to recreate, okay? Where, for example, if you want the multi-delegation recipe, this one here, we can, for example, add this is the number of addresses or keys sequences that we are going to be using. If we, for example, do this, 10, for example, we can create 10 accounts, 10 child addresses to do multi-delegation. We then go, okay, here we have the multi-delegation sharing, this one is sharing some part of the address. So I recommend, if you want to do multi-delegation and keep it anonymous as possible, without making your addresses trackable, easily trackable as a group on the ledger, you can use anonymous multi-delegation. And if you put, for example, a number here, 10, and you click Save Wallet Settings, this button here, and you follow these steps, you create a workspace on chain, and then every time you open your wallet, now in the future, in any other device, you will end up having a dialogue dialogue like this, a load wallet settings dialogue. And then you can recreate the same setup, okay, that you have stored or configured before. Yeah, so any question regarding this topic? Do you have a question on the chat?
Yeah, I believe I wrote something in there, but it's maybe too far advanced or ahead for this specific topic. Yeah.
Yeah, but okay, but very quickly, I didn't read the entire question, but if you go to demos, we have been using this function, derive keys, and this one, build address. But if we run this thing now, you can check on the permissions that it says generate volatile keys and volatile addresses. Okay, volatile, meaning that you can lose them. Those are dangerous functions. But if you go, for example, on the DAO demo, that maybe is the one you are interested in, and if I run the DAO demo, we are, for example, creating addresses and doing a lot of artifact generation here, and we don't have any permission that says it's volatile. Instead, what we have is a function that is called load config. And if you check inside, of course, you have a lot of more stuff, but if you check inside, there is some very similar syntax. For example, here we are deriving keys, but in a different way, under a workspace recipe or setup, not as volatile, independent temporal keys. This is the difference on what we have done today that is dangerous because it's volatile and you can lose those recipes. And if you use instead the load config and the save config functions, you can achieve the same thing, okay? That's storing it on chain, encrypted, and in a more safe way. the proper way on dealing all this stuff. And of course, we can cover this on the next sessions. But yeah, on this demo, we have a shared treasure created under this workspace. I mean, we are having inside our own wallet a wallet that we don't fully own or control. Okay, so for example, when we generate addresses here, this address is going to be called shared treasury, and instead of using public key hashes, references to the keys, we are going to be using script hashes or references to a native script that is also defined inside this workspace. And this is how we can, for example, pair ourselves to a DAO, to a shared treasury, to interact with shared funds or shared delegations or whatever. Yeah. Okay, guys.
Awesome. Thank you.
Thank you. Okay, so this is for today. So okay, Aaron, it was a very advanced maybe session, but yeah, if you want, we can then share you some other links and references to sessions that cover things more specifically related to what you are trying to do. And of course, if we plan it, we can actually maybe start building your app here, if you want. Of course, let's keep in touch. Okay.
Yeah, definitely. Thank you so much. It was interesting.
Okay, thanks for coming. You're always welcome. You don't need to be a developer here. Of course, it helps a lot, but this starting from the demos, understanding the basic of the syntax of this thing, you can end up doing quite a lot, even without coding too much. Yeah.
Is a good place to kind of keep track of when you have the meetings and stuff, just like the Twitter or
yeah, the Twitter is the best thing, but also let me share you the calendar, because I don't know if you know Gimbal Labs, but this is also an event that is inside this community called Gimbal Labs. That is an amazing community for learning on Cardano. I bet to say is the best one to learn on Cardano. So I am sharing you now the calendar of the entire Gimbal Labs. Events, weekly events, and then you have Tuesdays.
Okay, cool. Yep. Got that.
On Tuesdays you have hours, and today we are going to actually be covering some use case very similar to what you want to do, but in Spanish, late in the day. If you know Spanish, of course you're invited. Otherwise, we can plan this, of course, on English on these sessions in the future. But just in cases, we're going to be building, creating links to charge some crypto assets, ADA, maybe digit, whatever, to third party, to other people. So we can create a link, we can share that link to someone and make them pay us, for example, I don't know, 5 digits. This is the basic concept on how you could end up doing the app, your app. Payment links. Of course, if you have a payment link, you can encode it on a QR code. Okay, and you can scan that QR code and make a payment if you're a customer. So this is the basic concept. Today we are going to be covering it on Spanish. The next, maybe a next session, let's plan this. We can do it on English. And this is the basic technique that Martin uses on the payment hardware device. It's the same thing. Yeah.
Nick, the link
Awesome.
I've put on
Well,
there.
thanks so much. I appreciate it. Mhm.
Thanks to you all, guys. Well, I'm going
Oh,
to
yep, the
end the stream now.
Plutus PLB or